Alrighty, hi everyone. Let's go ahead and begin. It's almost spring break. Last class until break, so we have break next week. And then just to kind of remind you one final time, I know I've said this, but just to make sure everybody knows, no physical class on the 18th or the 20th after break. I'll be out of town presenting at a conference. Still available by email. So if you're working on even if you're still trying to work on catching up on homework assignments over spring break, let me know where you're at. Let me know what you need help with, so that we can get you all finished with those five homework assignments and ready to work on the project after we get back from break. I'm also going to be working to get caught up on grading. I still have assignment 4 and 5 left to grade, but that's my spring break catch-up project as well. And then when we get back, we're going to be focusing on just there will still be class, right? We're still going to be meeting, especially when the iterations are due for the peer review. But we'll still be meeting and talking about other topics that are more directly related to the project. So trying to introduce tools that will help you expand and improve your projects in various ways. So that's kind of the goal for after we get back from spring break. The goal for today is to get the project started. So I'm actually going to create the project right in front of you from basically scratch. And then after class today, you'll be able to grab your own copy of the repository, just like you do. It'll be in GitHub Classroom, just like you've done for many other assignments before in the past. But you're going to see everything get started from scratch. I like to give students a head start because getting started is actually really, really, really tough. And so people can get hung up on all the different pieces that are involved in getting a project started. So hopefully we can make it so that you can focus on actually coding and writing tests and the things that I'm hoping that you'll be spending time on for this project, and less about setting up Eclipse projects and repositories and things like that. So let's go ahead and get started. I'll try to remind you of the various parts of the project along the way, because there are a lot of, not a lot, but there are 5 parts that you're being graded on. So I'll try and touch upon all those pieces as we go along as well. To get started with, I've actually already created a GitHub repository for the project. I just set this up right before class. It has a README file in it, which eventually I'm hoping that you will, add a description of what happened each iteration, right? But that should be an easy retrospective thing for you to do towards the end of an iteration after you've completed a cycle of work. As far as the repository itself, there's absolutely nothing in it. So we need to get an Eclipse project in there and get ready to start writing some code. And then I actually want to write a little bit of code with you today, go through that process again of what I'm expecting you to do when it comes to adding pieces of code to the project. So I'm going to start by cloning this basically empty repository onto my computer. I'm just in my home directory right now. It doesn't really matter. And you won't be able to do this again until after today's class. So just sit back and enjoy the show for now. You'll get your chance to do this once I open up the project for you to start working on GitHub Classroom. But we're going to go ahead and clone this right here. And then I'm going to tell Eclipse to just go ahead and create a new project in that repository. So I'll select a new Java project, and instead of using the default location, I'll tell it to use that location where I just put the repository, which is called base project somewhere in here. There it is. That's where I want it to go, and we'll call it something like that. Okay. Sure. So now underneath all of my other Eclipse projects for all of my other classes, well, including this class actually, you can see I've got this one for the 237 project. And now we need to focus on what we're going to start doing. What are we going to start adding to this project? How we're going to start adding pieces of code to this project. So the first step is to get organized. Once your team is able to create a repository, one of the first things that you're going to need to do is create your little board to keep track of what tasks exist and who is responsible for those tasks. So you're going to need to go up to the Projects tab. You're going to need to create a new project. The one that I used last time was the Kanban one. That's the one that I like. I have to be honest with you, I guess I'm not too terribly picky about which one you use, as long as the team is familiar with how to use it. But this one I feel like is pretty simple to work with, so that's the one that I recommend working with. And I actually even try to make this even more simple by eliminating some of these lanes that I don't consider to be necessary. So I'll usually delete this lane and just keep it to a simple 4-lane system where we've got basically all of the ideas queuing up over here on the left-hand side, and then they progress towards the right as they are completed. So that's what we're going to start doing, is we're going to start by filling up the list of ideas so that we can have some actual work to do. And I guess we need to talk about what the project is that we're going to be working on. I promised you it wasn't going to be anything fancy or flashy, and that's absolutely true. We're going to make a system for keeping track of bank accounts and transferring money between accounts and depositing, withdrawing, and all kinds of other directions that this could go in. But we're going to start with the basics. We're going to start with the very basics. It's going to be like a glorified ATM system, I suppose. You can think of it that way. Again, not something that's going to be terribly fun to show off or play around with, but it gives us a lot of different directions, a lot of different things that we can code up and include, and a lot of different ways to practice some fairly practical coding skills, which is what we're after. So we're going to start by keeping it simple, coming up with some of the basics. So when most people think about bank accounts, they think about depositing money. But we need to express this in a need for our users. So the terminology that I'm hoping that we'll use is something like the customer should be able to deposit money into an account, right? And you can probably imagine there's a similar one for withdrawals. Notice I'm being very generic here, an account. So there's a bank account that exists. We should be able to deposit and withdraw from it. That's all we're really looking for. Notice that there's not even any notion of like having to log in to do this or needing a PIN number or anything like that. That's all different stuff that certainly can be included, but are worthy of having their own tasks made for them. So having their own user-defined needs, right? If that's a direction that you and your project decide to go in. So this will be one of the first things that you and your team members are going to have to do. In fact, I'm hoping that maybe we'll have some time at the end of class today, since everybody's here, or most people are here, for you to have a little brainstorming session. Create these before you leave so that you have an idea of what to work on. Yeah, this is kind of step one, and I'm going to go through at least one of these, or maybe both if we have time, and just again kind of get you used to the process of how I want you to approach this project, the steps I want you to take as you tackle the tasks that you and your group come up with. So I'm going to start with the deposit one. It'll be assigned to somebody in my team. I'm just going to go ahead and assign it to myself. Obviously, you and your team members will have to make the decisions as to how to divvy up these tasks. I want to make it clear, though, that everybody's expected to contribute to the coding portion. I don't want there to be some concept of like a team manager that's just telling other people what to do. No, everybody's an active contributing participant to this code base, right? Everybody's on the same level. Everybody is actively trying to develop this code. So I hope to see that everybody is assigned at least one task, right? One coding task on this board for every iteration. That is something that I'm specifically going to be looking for when I go through and grade the project myself. So I'm going to go ahead and assign this to me. Once that's done, we have some work to do on the repository side. We need to set up our development branch and then also our feature branch. Now, by the time you get this repository, remember I'm working on the same repository that I'm about to give to you all. So by the time you get here, the development branch will already exist. So I'm about to create it right now. So you won't have to do this step. You won't have to create a development branch. I just created it for all of us. That branch will be there for you to use. But you will be expected to create branches for each individual feature that gets added to the project, that gets added to the code. So that means that I expect to see one branch for each of these tasks, one branch for each of these cards. Okay? I've said this before, I'm going to say it again because it's a common thing for people to want to do, to make a branch based on who is working on that particular task. I don't want to see people's names in the branches. That's not an appropriate part of naming a branch. I also don't want to see things like a branch just for testing. Testing is part of the entire process. If I'm adding a piece of code to the project, the tests are also part of that. I also need to supply the tests that show the code is working properly. That's my responsibility. That's part of my contribution. So the branches really should be broken up by these tasks. And these tasks then are rather broad, right? They require touching perhaps a lot of different parts of the project to make sure you've got all the different pieces that are required to implement this task properly. So let's go ahead and get started. We're going to need to, create some classes and other things to keep track of the various parts of our program. I think most obviously we're going to need a class to represent a bank account. But we're going to need more classes than that, I promise you. It's going to be not just a simple... Actually, I forgot to make a branch, didn't I? I forgot to make my feature branch after that long discussion about making feature branches. I forgot to actually do it, so let's do that. The branch should be called something like deposit. It's fine. Okay, there we go. That's better. So yeah, one of the main things that I'm hoping to get you all started off with today are some starting points for the objects, because that can be another very tricky part of getting started on a project, is knowing what classes to make, trying to give you a big push in the right direction. Although I'm also expecting you to have to add more and modify the code that you've been given as you progress through. But I also want to encourage you to think about the test-driven development part. So what I should have actually done is created a separate package for my test code. This one we'll call bank app. So we've got one package that has the actual application code and then one for our unit tests. And what we can do is start by writing the unit tests first. So the way to keep your unit tests separated is by class, typically. So if I'm making a new class called bank account, I would expect all of the unit tests for the bank account to be in its own separate test file for those bank account tests. So keep that in mind. I'll end up probably creating a couple of test files today because we're going to create a few classes. That's typically how we're going to break it up. So bank account tests. Yes, we do want JUnit 5 added on the library. That's the unit test library we've been doing. And we've already done this part. We're now looking at unit tests, and we need to start writing some tests to define the behavior that we expect our bank account to have. So we're focusing on deposits right now, And so I think there are some obvious simple tests that we can do. Oops. Step 1. What's step 1? Set up the objects. So we're going to need to create a bank account. I'll call it a test account. And already we have to make a decision. What input values should we have when we create a new bank account? Should a bank account accept a dollar value in as its input, or should it just start at 0 every time? Honestly, there's no wrong answer to that question, right? There really is not. It's up to you to a degree and the way that you envision this project going. Personally, I favor to just keep it simple, have no parameters there, and just assume that it starts out at 0. Every bank account starts out at 0. If you don't like that, you want to switch it up, that's okay. Or actually, you can have it both ways, right? You don't need to be limited to just one way. You can have it both ways. You can have a constructor that starts at a 0 and another one that accepts a new balance. Both might be useful for different purposes. Don't be afraid to make that choice and add that in if that's something that you think needs to happen. But by doing it this way, I think, right, think about the implications of, okay, if there's no information going into this object, I'm assuming it starts out as 0 balance. What else could it be? What else logically makes sense? Probably, it's not going to start at some random value. So then we need to move on to step 2, which is, what's step 2? Call the method being tested, which in this case is going to be to deposit some money. We're just going to do a simple deposit of $25. Oops, I forgot to call the method. I need to do the dot deposit. And then finally, we're going to move on to step 3, use assertions to verify our results. So we'd probably assert equals that the expected value would be $25 back from the account when we ask it to give us the balance. And recall that with doubles, they're not exact, so we have to provide this third value, which is a tolerance value. We've seen this before. It's just an error tolerance that we allow in order for the test to still pass. We say there can be that amount of wiggle room. This allows them to be off by a penny and still be close enough. Pennies are basically worthless anyway, right? I don't know. Maybe that's not a fair thing to say. I have a jar full of them at home, but okay. There's one test. We're not going to stop there, though. We actually need to try and think of other situations in which we might try to deposit that we need to account for. And in particular, this one presents an interesting situation to us. Typically, we consider depositing as a positive action. I'm giving you $25. But an interesting case might be, what if I try to deposit a negative value? That's kind of a strange thing to do, right? A little odd. Not something that we would normally expect to happen. How should we react to that? Well, let's write a test that defines how we would expect our code to react to that behavior. I'm just going to copy this test and use it as a basis, since it's going to require some of the same pieces. We'll rename this to be test negative deposit. We still have to construct a bank account object. We still need to call the method being tested, but this time we're testing with a negative deposit, right? And now we have to figure out, what do we want to happen? I can think of a couple ways that this could go. We could just ignore it. We could just be like, well, that's a weird thing to say. I'm just going to pretend you didn't say that, right? And just leave it alone and just not do anything. Just leave the balance unchanged. I don't think that's unreasonable. The other thing that we could do is we could raise an alarm. We could say, hey, this is a really weird thing that should not happen. Something took a really weird turn, right? So somebody needs to look at this and figure out what happened. I think both are acceptable. I think that testing the first one is pretty straightforward. Testing the first one would be pretty simple. Testing the second one is also doable, and I think kind of interesting. So I'd like to go through that approach with you now. The act of raising the alarm, of causing an error. We talked about this a little bit, right? Does anybody remember the Java terms for the red stuff you see at the bottom of the screen when your code crashes? Starts with an E. Exceptions, yeah. So if we wanted to indicate that this is a problem, that means that the method needs to throw an exception when this happens. Say that, hey, this isn't allowed, this is an error, this should not be a thing that takes place. In our code, in order to reflect the fact that an exception is going to take place here, we would actually need to use a try-catch block, right? And then catch the exception that we expect. If the exception doesn't get thrown, if we proceed through the try-catch block without throwing the exception, then we can say the test is failed, because that shouldn't happen. The exception should get thrown. Does that kind of make sense? So let me type it out into code and show you what I'm actually saying. Oops. I think the type of exception would be an illegal, oh gosh, spelling and me do not get along. Argument exception. That E looks weird to me. Is it not supposed to be there? Help me out, Eclipse. Okay, Eclipse is mad about other stuff. Oh, I got it. Whew. Okay. Yeah, so this is where we expect to go. Right? Negative 25 is bad. So we expect to end up here. So if we get here, that means we want our test to be like, yeah, we did it. That's good. So we can honestly just, say, yay, we did it, right? The alternative is to, and actually both might be required, would be to come up here and say, actually I think you could just say, what is it, fail? Yeah. If it gets past this line and doesn't throw an exception, doesn't jump down here to the catch statement, then we didn't successfully pass the test, right? That means that it accepted the negative 25. We don't want to allow that to happen. We want that to cause an error. So this is how you can actually test that your code is properly detecting bad inputs. I think this is a nice, interesting way of thinking about what tests can and cannot be used for. You can really write unit tests to help you check for all kinds of coding behaviors. I'm trying to think if there's any other edge cases that we might need to consider testing. I'm not. There very well may be, but for the sake of kind of keeping things moving along, I'm going to switch to the next part of test-driven development that says, okay, we've now written at least one test for the method. In this case, 2, and ideally more. If you can think of more cases that you want to test, then by all means, more tests is always a good thing. Now we need to write the code that makes these tests pass. So I'm going to go into my bank account class, and we actually have to think about what this is going to include. I think it's pretty obvious that there's going to be balance. We've already specified in our tests, we made the decision, or rather I made the decision for us, at least for now, that the bank account constructor is not going to take in any, oops, wrong click, is not going to take in any parameters. So we don't even really need to think very hard about how we write this part of the code now, right? We've already made those difficult kinds of decisions design decisions by writing the unit tests to define the type of behavior that we expect our code to have. So we'll start our balance out at 0 like we've talked about. And now we need to think about what other methods are required for us to start to... Here we go, we need to import this guy. That takes care of that error, yeah. So now it found our constructor. Now we need to write our deposit method. Needs to take in a value, right? So if all I was worried about was passing this first test, that would be very easy. I would just say this dot balance plus equals amount, right? At this point in time, I should pass at least one of the... Well, I need to write one more method, don't I? I need a get balance. I need a getter. Okay. There we go. Yeah, so there's no more errors because I have written all the methods that were used by the tests, and now I can actually run the test and see that it should pass at least the first one. Yeah, it did. I got the green check mark for the first one, but I didn't get the green check mark for the second one because it didn't throw an exception when a bad value is passed in. So we need to implement that. We can do that by using an if statement. If the amount is less than, I guess 0 is okay. Depositing nothing is, maybe we need a test for that. What should happen when we deposit nothing? That's, if I'm asking the question, right? It's almost worthy of having a test. It doesn't seem like it should be an error. It just seems like maybe it should not do anything to me, although it is a little strange. But anyway, if the amount is less than 0, we're going to throw a new illegal amount must be positive. So we throw the exception. The exception type that we choose here tells us that this is an illegal argument, right? It tells us about the error that is occurring. And then we provide a message. In this specific case, it says the amount must be positive, a positive value. We discussed before about how these exceptions get passed up the method call stack until somebody handles them. And actually, in this case, what's going to handle the exception is the code that we wrote over here in the test, this try catch. Last time, before I wrote that little snippet, we did this. We deposited the money, and then the test failed because it was expecting an error to occur. But now, I've actually implemented the error. So we should expect to end up here, and hopefully the test is going to pass. Let's rerun the test and see if that happens. Wonderful. Wonderful. That's cool. I like that. That's good program design. We're actually not done yet, though. If I was working on this, so should have done this earlier, moved this to the in progress position. It's tempting to think that, okay, we've done it. We made the bank account possible for it to take deposits and so on and so forth. But actually, we're not done yet. Remember the way that our tasks are written, the customer should be able to deposit money into an account. So right now, we've got code that allows a programmer to deposit money into an account. I'm not going to expect some random person walking up from the street to say, bank account equals new bank, right? Like, they're not going to know to call a constructor and then call the deposit method. That's my job to do behind the scenes, and then I need to set up a nice interface for them to use so that they can tell me what they need, right? We've all used ATMs and stuff like that. All the methods are happening on the computer in the box. We get to see the buttons and options that we get to select. So that's another part of completing this task. is what we would call more of the back end portion. Now we're going to switch and talk more about the front end portion, which for this class we're going to keep it very simple. It's just going to be a command line application, right? We're not going to do buttons and things on the screen. If you want to take web dev and learn how to make fancy websites, that's a great class for one thing about it. But that's not this class. We're going to use scanner and print statements to present options to the user. But that is part of this task, and I want to complete that as well and get you started on that, get you started thinking about that. So what does that imply in terms of our class structure? That implies that there is another object. There is a menu, right? Or a menu system, something like that. If the project gets big enough, if it ends up having lots of menus, then having one menu class may not even be sufficient. It might be worthwhile to have classes for each of the different sub-menus to help organize the code. But for now, we're just getting started. We're just keeping it very simple. So we're going to create a very simple menu class. And think about what we need to happen. So far, we're not interested in, again, PIN numbers or accounts or anything, usernames or passwords or anything like that. We're just, the task that we're on is a user should be able to deposit money into the account. So what do we need to do to make that happen? We need to ask the user how much money they want to deposit, and then we need to put it into the account. That's it. That's really all that we need to do. Later on, when you get to managing lots of users with different accounts, those will be different tasks that require you to implement different parts of the project, right? So right now, we just need to ask the user a simple question. And I'll just go ahead and put my main method in here because I think the menu is where we expect our program to start for our users, right? We don't expect them to start with the bank account class. We expect them to start by using the menu. And I'm actually going to start by doing this kind of the 131 way, where I just cram everything into main. And then we'll go back and try and factor some methods out of this and talk about testing too, because I think that's important as well. I'm tackling this a little bit of the opposite direction, right? Not writing the test first, and write the code first, and then clean it up a little bit and talk about testing. So first thing we need to do, we need a scanner. This is pretty standard stuff. We also need to ask the user what we want. Okay, and then we'll wait for them to type in the value. All right, and then finally we need to do the thing that they requested. We need to take the value that they gave us and then put it into the account. We actually don't have a bank account yet, but we need to make one. There we go. And then to justify to the user that the deposit went through, I'm just going to put in another print statement to say something like that. All right. It's not a whole heck of a lot of code, right? But it is at least more user-friendly than having to call the methods directly. We ask them to type in a value, and then we demonstrate that it gets typed in properly. How much do you want to deposit? 50. Balance is now 50. Perfect. What about the other way? What if we say, how much do you want to deposit? -50. Oh, there's our exception. That's kind of cool, right? It says amount must be positive. Hey, that's their message. That's pretty cool, right? That's the exception that our code threw. There's nothing here that's ready for that. How should we handle that, actually? I think that it would be wise to maybe validate that value before it gets that far so it doesn't crash. So I think this is something we talk about in 131, for example. We would maybe use a while loop here. While amount is less than 0, then we're going to keep asking them the question, right? Yeah. Don't need the type here. So now we'll avoid this situation by just repeatedly prompting. To be fair, we should probably also have a message saying, you know, invalid value. Okay. Something like that. Okay. So this is a bit better. And then eventually I say 60, and it says your balance is now 60. Okay. I would say that by the terms of the task that we've set out to complete, the customer should be able to deposit money into an account. We have succeeded. However, if we think about what else we care about on this project, we have not yet fulfilled all of our obligations. This is not an acceptable main method. There's no methods being used here. Actually, this menu class is going to be something that I think you and your team are probably going to be spending a fair amount of time on as you add more and more things to the project, right? This code needs to be cleaned up. There's also no tests for it. So what do you do if you find yourself in this situation? Yeah, maybe I wish you would have written tests first, but I understand that that's not always going to happen. I've been in this spot as well. Well, let's think about it. Let's try and extract out methods of value. Clean up this main method, make it as small as possible, and then think about testing as well. How can we test what's in this code? Because there are some things that are tricky to test here. So one thing to think about, there's no objects being used at all. Everything's in main. Menu is a noun. That's a thing. Right? Menu is an object. So let's treat it like one. What are the things that are happening here? I have a prompt where I'm displaying the prompts to the user. I have a validation component where I'm making sure that the user types in a proper value. And then I have whatever action the user has requested, right? After they've given me the appropriate information. So there's really kind of three pieces that are happening. Display menu prompts, display menu options, right? Retrieve input from the user, that's step 2, and then do the thing that the user has told you to do. So if we try and think about what the menu might look like if we use methods for this instead. Well, first let's talk about the constructor and the instance variables. That's a little bit tricky to think about, but the one that I see is right here, the scanner. The scanner is one that I think the menu is going to want to have access to so that it can accept user input when it needs to. So I think part of what we're going to do here is create, actually this should go way up at the top, not there. This main method is in a really awkward spot, but that's my fault for putting it there. We're going to fix it. There. We're going to make an instance variable for our scanner, and then in the constructor, we'll initialize our scanner. So the three things that I talked about were displaying the options, then getting user input, which in this case was a double. We could even say valid user input would be better. And then the third task was, processing user selection, something along those lines. Every interaction that we have with our user is going to go through these three steps, right? We display some prompt, some request for our user to interact with us. They provide interaction by entering input, and we keep asking them until they give us input that is valid, and then once they do, we go off and do whatever it is that they've validly selected for us to do. So if we try and think about this in the the scheme of what we've got here, our first step is to separate out the stuff by those three pieces. It's a little bit tricky because there's really just not a whole lot going on in this code first, for starters, but I think once the menu expands out, these methods will get larger, and well, let me just yeah, one step at a time. Okay, I forgot a return type here. Sorry about that. So I've sectioned this main off into the three pieces, and what we're going to do now is reconfigure main to call these methods instead. By calling our constructor. I do see an error down there that I need to fix, huh? I probably need to add a return statement. We're going to display the options. We're going to give valid user input. And then we are going to process the user selection. We need a return value here, so that's going to be amount. Here it's trying to access an account. Since it can't do that, that's an indication that perhaps that is going to be another instance variable for us. We do need to have a way of keeping track of what account we're interacting with. The processing user selection method is also likely going to take in whatever value is been perceived to be valid. So in this case, that would be double amount, right? Which means that up here, we actually need to tweak our main method to reflect the fact that the return value from here gets passed into the following method call. So we'll grab the return value, pass it in. Now everybody's happy, and our code has been refactored. Our main method is actually a lot smaller. In fact, I might even go so far as to say that these three lines of code could be extracted out into even an additional method to run the menu. Part of the reason I say that is that at some point in time we're going to start including options here. In fact, maybe I should have started by including options such as, do you want to deposit or do you want to exit? Something along those lines. But that actually sounds like another task. A user should be able to exit the system. Sounds like another task you put on your task board. Regardless, let's talk about testability. I think it's good to talk about testability, especially when it comes to user interfaces. This is a question that I get a lot because I am pretty adamant about having lots of tests, but not all methods are testable. So let's take a quick review of the code that we've written so far and talk about what methods we have tested, what methods we haven't tested, and what I'm going to be expecting, right? Constructors, not tested, right? I've never written a test for the constructor in this class. I don't plan to. This is just a regular public method, right? Public method doing some work. Lots of tests. As many as I can think of. Getters and setters. Not tested. Not going to write tests for those. If we think about our menu class, this is a constructor, so we already know that's not tested. Main method, we're definitely not going to test that. But let's talk about these, those three pieces that I just discussed about displaying getting valid user input, and then processing the user selection. I think that these are things that can be tested, but for the purposes of the project, when it comes to code that just displays stuff, no tests needed. Can you test code that displays stuff on the screen? Notice the only thing that's happening here is a print screen, right? That's all that's happening. Can you test code that just displays stuff on the screen? You can. In fact, there's a whole branch of computer science that's concerned about this, human-computer interaction, right? It's very concerned about how information gets displayed on the screen, how it's done effectively for our users. But that's not this class. So while I may talk about this in the future, perhaps after spring break if we have some time on the schedule, I'm not going to expect you to do this on the project. This one, getting valid user input, think about the trickiness for this. When you call a method like this, it just sits there and waits, right? The computer just sits there and waits for somebody to type something in on the keyboard. So how do you write a test to mimic that behavior? You actually can. But for the purposes of the project, I'm going to say no test needed for now. This is a topic actually I'm very interested in discussing in the future, so probably discuss in future class. Right? After spring break, this is pretty high on my list of topics that I want to talk to you about. I like talking about testing. I think it's a very important skill to get the hang of. So, but then this one, step 3, does work. Needs tests. If you think about it, this third method, this third category of method is actually going to be bridging the gap between what the user sees and what happens on the back side, right? Making sure that the user says, I want $50 to go in. The methods get called properly on the proper objects, and the money actually goes into the bank account. So these absolutely do need tests. I don't know that this is actually in a state where it can be tested right now. I think we would need at the very least to have a getter here. So public okay. Now I think we actually could start writing a test for this menu, and I actually think that we should write a test for the menu. Again, it's important to test, provide as many tests as possible. So I'm going to create a class for the menu tests. Oops, I did that the wrong way. Not a class. It should have been a unit test. Sorry about that. There we go. All right. I'll write a test for testing a user deposit where I need to set up the object, which means creating a menu. And then really the method that I'm testing in this particular case is this one, processing user selection, right? So step 2 says process user selection. So this test is operating under the assumption that the user's provided a valid input of 50, and then we'll assert that if we, we need to retrieve the bank account from the menu, and then assert that the balance in the bank account actually made it with a tolerance of a penny. Assert true. Assert equals, sorry. Assert equals is used for comparing two values. Assert true is used to test for boolean true or false. Yeah. So here's how we would test the interaction between the menu. This is actually making sure that if the user does this thing, that the bank account underlying, on the back end is actually affected properly. We can run this, make sure that it passes. It doesn't, and I actually kind of expected this to happen. I think I forgot to do a step. It says we got a null pointer exception on this line because account is null. We never actually initialized a bank account here. So that needs to happen as part of the constructor. Let's fix that error that our test helped us catch and then run it again. Perfect. That works. Wonderful. And now, finally, after all of that work, which, again, I want to reiterate, a lot of what I did was setup. So you're not going to have to obviously create all those classes and constructors and stuff. You're going to have all of that at your disposal. But all of what I have done is actually what I would consider to be required to complete this task, to complete the task that I have. So now that I've done that, we're ready to do the commit and push process. I'm going to add all the stuff that I can. We also, actually, I need to add these two files as I've talked about in prior class to reflect the fact that I'm adding the Git, the Eclipse project here as well. So I'm going to add .classPath and .project. And now I can commit. And now I'm going to push base. Oh wait, what was this branch called? It was called account deposits. There we go. That's great. Love that. Where'd my repository go? Here we go. All right. There it is. There's my branch. Great. With the commit status. Awesome. Perfect, perfect, perfect. So at this point in time, in the project, you would be ready to, that's a great name for the project. You would be ready to move this over to review where your group members would check out your stuff. I showed you last time how you could actually link this to a pull request and thing. You don't have to do that. Don't worry about that for iteration 1. Maybe 2 or 3 we can talk about incorporating pull requests into this process. But for now, I think just getting used to the idea of making stuff into branches and then committing and pushing those branches is sufficient for us. And then once your group members have signed off, that one's done. You're all good to go. You can move on to the next task. So, the one final piece that I want to mention before I forget is that as part of the functionality criteria, you are required to make a script. That compiles and runs your code. So I'm actually going to give you a push in that direction as well. I'm going to go ahead and make a new script. This script really should just have, I think, 2 commands. There should be a call to Java-C to compile the code, and then there should be a call to Java to run the code. I've talked about this before in prior classes. I know it's on prior videos. This can be a little bit tricky. This is a sticking point for some people, but I want you to take a stab at it. If you get stuck, send me an email and I can give you some tips on how to get this up and running. But this is something that you are expected to do as well. So let me add this script and commit that as well. And then actually, once once everything has been marked off as finished, actually, I should mention that the final, most finalist step is to move back to your development branch and then merge this branch into the development branch. And then finally, I will push the development branch to the repository. And I believe with that, everything is set up for you to use. I do want to do one final recap, though, of how you should be approaching this project, because there was a lot of extra stuff that I had to do that was mostly set up today. So I want to try and, again, make it exactly clear what's expected of you, as opposed to all the extra setup stuff that was done. When you get access to this repository, which is going to happen in just a few minutes, I'm going to click the button to release this repository to you all as soon as I'm done yakking about the project. I would like for you all to get with your groups, make your project board, and start brainstorming. I'm not going to tell you what direction to go in, so if you want to keep the app simple and focus on, very basic deposit withdrawal things, or if you want to expand on the user side, make logins and PIN numbers and all that stuff, it's up to you and your group mates what direction you want to move in. But have a brainstorming session about what tasks you want to add and how you might approach that process. One thing that I do want to point out about this menu, I expect this menu actually probably to require some thought from your group. This is a good start, but as you start adding more menu options, right, I think it's going to require a bit more thought as to how these are going to start to play out. So for example, I would probably expect to see, 1, deposit, 2, withdrawal, right? 3, make new account. I don't know. Is that something you want to do? That's up to your group, right? A user should be able to create a new account that's associated with them. That's up to you and your group members to make decisions on the actual direction that you want to take the particular project. If you're struggling with ideas, then hit me up and I'd be happy to give you a push in a particular direction. But I did want to provide at least some flexibility for you to have a say in the direction that this project goes. So consider that as this menu grows, processing the user selection probably isn't just going to take in a double for the amount. It's probably going to take in an int for the menu choice, right? That they chose. So this is probably going to be, oh, they chose option 1. That means I need to do a deposit now. And maybe you'll have a whole separate menu just for deposit, right? To make sure that code works properly. That's, I think, a reasonable thing to consider. But yeah, a lot of that's going to be up to your group. Again, happy to provide input when I can. I know that a lot of these questions are open-ended. There's not always necessarily a right answer or a wrong answer, which can feel very intimidating, but that's kind of what I'm here for. I can help put my finger on the scales if you want to think about a particular direction for your project. So, I'm trying to think if there's anything else that I forgot. I really don't think that there is. So when we come back from spring break, again, remember, I'm out this week, but when we come back from spring break, I plan to talk about files. One thing that you won't be able to do without incorporating files is make any of this stuff permanent. You'll have to create a new bank account every time from scratch, right? And add stuff to it every time from scratch. So files is one thing that I usually like to talk about pretty early on to allow you to have some persistence with your applications. If you want to poke around with that before I get around to it, please don't wait on me. If that's something that you and your group is interested in tackling, then make a task for it on your board and start adding it to your project. But when you come back, especially on the 27th, that's going to be our first peer review day. So I'm actually going to go through the peer review process in class that day. I'll actually fill out the peer review form with you kind of all together as a group, especially the first time, because I know it's the first time for y'all to do a peer review process. But by the time we get to class on that date, I'm hoping that you will have, at the very least, some cards on here. Some of them will hopefully be over in the done section, right? Don't freak out if some of them are still in progress, or hopefully you have a backlog, right, as well, of ideas that you're intending to get to in the future. Okay? But quality is what I'm really concerned about here. Always, always, always focus on those 5 criteria: code quality, testing, repository friendliness, um, functionality, and I don't remember the last one. Oh yeah, the project management, the one we're looking at right here. All right. Any questions? I wanted to leave some time at the end today so you can meet with your groups and start brainstorming project ideas. I know I covered a lot. Are there any questions? Anything else you'd like for me to talk about before I kick it over to you all? All right, give me just a second to turn the link on for the project, and then you all be able to start making your repositories. Cool. So if you go to the iteration 1 page on Canvas, you'll see a link. It says click here to create the team in the repository. I believe that should be active. So go ahead. You just need 1 per group. If you can keep the team name at least somewhat reasonable, I appreciate it. Some combination of your names is pretty good. But yeah, that link is available to you on Canvas. Go ahead and get with your teammates. Let me know what I can do to help you get started. We've got time to talk about this before you leave, so let me know what I can do to help.